Hi, my name is Brian, and my partner is Robert Gare, and this is our research paper, a virtual reality training simulation to assist in high-fidelity baseball batting using Oculus Quest 2 and Unity Engine. It all started when I joined the Flinters Prep baseball team. My coach has always told us to appreciate what we have instead of complaining about what we don't. We are fortunate enough to practice baseball even though we don't own a field of our own. And if some private schools out there lack some of the resources for practicing baseball, I'm sure that many kids and adults in the world do so too. The problem continues. Kids can't drive, but they account for the majority of baseball players. As a result, their parents are the ones who have to take them to practice every day. However, not all parents have ample amounts of free time. Many work jobs and prioritize feeding and sheltering the family. The issue with not having resources and not having time to go to batting cages is that the player will not be able to practice at all. After all, just swinging the bat over and over again counts as practicing. Instead, not having resources and not having time to go to the batting cages will result in less beneficial practice. What I mean by this is that by going to the batting cages, one is able to see where the ball that they hit goes to, and is able to adjust their swing or their stance so that each hit looks and feels perfect. Practicing with no way to adjust leads to not being able to improve at the same rate as your peers, which in turn leads to being benched during a game or even worse, hating the sport because you are not good enough. Our solution is a virtual reality baseball hitting simulator that allows players to practice hitting and to be able to face live pitching at home. The main structure of the program can ultimately be described by four systems running in parallel: the player input system, the pitch generation system, the baseball force simulation system, and the bat collision detection system. These four systems run continuously throughout the program's operation and continuously pass relevant output data to each other that is then interpreted uniquely by each system in order for them to successfully fulfill their purposes. The player input system. The purpose of this component is to take in the data of the player swinging the bat and to transfer that data into the computer so that the player can interact with the simulation. The player input is received through the VR device and the data is handled by Unity's XR Toolkit library. From there, the data goes through the other systems of the game, including baseball-to-baseball bat collision detection and player camera and player hand position adjustments. The pitch generation system. The purpose of this component is to facilitate the continuous generation of new pitches to be thrown towards the player. In order to create this system in a simplified way, we distilled the concept of the human pitcher into two simple concepts: a timer and a single action of initializing a pitch. Additionally, the pitch system includes the concept of a pitch preset with the random preset being applied to each pitch action. These pitch presets change the nature of the pitch. For example, there's fastballs, there's curveballs, and there's sliders. The baseball force simulation, the baseball force generation system. The primary function of the baseball force generation system is to update and apply the forces of the baseball based on the unique pitch parameter data that it was given. In order to create a pitch that behaves realistically, the baseball force simulation system accounts for air pressure forces generated by the fast rotation of the ball in the air. The bat collision detection system. The purpose of the bat collision detection system is to translate the movements of the bat through the player's input into data that can be interpreted by Unity's physics system, and then inserting that data into the physics system so that the baseball collisions are handled by Unity in a way that takes into account the player's real-life movements. Why our solution? This solution solves two major problems. One, players will not be wasting time sitting in cars going to and back from the batting cages or field. Instead, this lost time could be spent practicing more. Another problem our solution solves is not being able to reserve a field. Because fields are limited and Little League and high school teams get priority when practicing on them, it is hard for those who want extra practice to be able to do so. With our solution, having somewhere to practice is no longer an issue. One can practice whenever they want, however they want, as long as they have their VR headset and their laptop to connect to. We believe that this solution is effective because it directly addresses many of the key factors that prevent people from practicing, as well as provides a way for players to get better. And now for a video demo. So basically, right now, I'm going to explain to you and demo to you how this works. So I run the game. put on my VR headset, and then as you can see, the thing that I am holding right now is the actual baseball bat in the VR world, and then the pitcher generates random pitches at a random time interval so that it gives you that uncertainty that you feel when you're actually in a real game. And then right now I'm going to go through all the pitches. There's a fastball, there's a curveball, there's a slider, there's a changeup, and then whichever one I select is basically the one that you can override and that the pitcher will always be thrown to you. So right now, for example, I put one. One is a heater fastball, which just means like a really fast fastball. And then yeah. Back to the presentation. Experiments. The biggest reason why I made this program was to create a way to help real-life baseball players improve their baseball hitting skills. And so I decided to create this experiment, which was see if my simulation actually helped baseball players improve and get better. To test whether or not my simulation actually helped baseball players, I selected baseball players at random and took them to a batting cage. There, I had participants swing 5 times from pitches thrown from the machine to see how many solid hits they got. Then afterwards, they used my simulation and swung 5 times according to pitches thrown from the machine. Afterwards, they took off my VR headset and swung 5 more times to the machine to see if the amounts of solid hits they got increased. If it did, then it showed that they improved. From the data, it can be seen that most of the participants improved with the usage of my VR simulation, which made me happy because it is evidence that the program that I created will be able to help other kids and adults practice and get better at baseball. A second experiment that I conducted regarded the level of entertainment my simulation gave to certain age divisions. I believe that having fun is more important than anything else, and if I'm able to help others experience joy, I myself will also be happy. For this experiment, I experimented 5 age demographics: ages 7 to 12, ages 13 to 18, 19 to 25, 26 to 35, and 36 to 50. They were all people I found at the batting cages and who gave me consent to experiment on them. At the end of using my VR headset, they filled out a questionnaire and gave their honest reviews of how much they enjoyed using my VR headset to play baseball. Currently, I am developing a sensor that can be attached to a real baseball bat so that instead of swinging the VR controller, one would be swinging a baseball bat instead. Personally, I believe that if you are going to practice, you should be practicing as if you were in a real game. In a real baseball game, hitters will not be swinging a VR controller. They'll be swinging a real baseball bat. Furthermore, even though the user is in the VR world, by being able to swing a real baseball bat, the user is able to develop more feel for the bat, which in turn allows them to generate more confidence in a real game due to the extra reps that they are getting in. Unfortunately, I don't have the model with me at the moment, but the sensor is attached to a knob of the bat and is connected to the laptop using cables. Once it is connected, moving the baseball bat in real life translates over to moving the VR baseball bat in the VR world. In conclusion, I created a training mechanism for baseball hitting practice using the Unity game engine and a VR headset. Based on the data of the experiments discussed above, this training mechanism was proven to be effective. Those who trained with this VR training solution showed improvements in real-world baseball performance compared to those who did not, which suggests that more developments towards training systems in nature should be pursued. While the training system developed in this paper was successful, it leaves many areas for future improvements in the realm of immersion, realism, and tactile sensation. But we believe that further research in baseball training solutions that utilize virtual simulations would be worthwhile. Here's my contact information, and thank you for listening.
Yeah, thank you, Brain. It was a good presentation. And I would like to know if any questions from forum. Okay. Okay. I think there are no questions. And once again, thank you for your presentation, Brain.
Thank you.
Yeah. Now I would like to welcome Kate Kyo from USA and Joshua Wu from California State Polytechnic University, USA, entitled on a smart task management and schedule suggestion mobile platform for efficiency improvement using artificial intelligence and machine learning. So are you there, Kate? Are you there?
Sorry, are you asking for me?
Yeah, I think you can share your screen and go ahead with your presentation.
Okay. Yeah, let me pull that up. Sorry, mine was scheduled for like 9:30, so I don't have everything pulled up right now.
Okay.
Um, okay. Here it is. Okay.
Yeah. Yeah, your screen is visible. You can go ahead.
So this is a presentation on a smart task management and schedule suggestion mobile platform for efficiency improvement using artificial intelligence and machine learning. So there is like a current mental health crisis in the United States where many adults suffer from depression or other just anxiety disorders. This graph helpfully shows that overall around 20% of US adolescents and 8.3% of US adults had at least some major depressive episode in 2021. And this just is like a worrying trend because this has been improving or increasing in recent years. So there are many other online treatment methods, such as online therapists and mindfulness apps and mental health trackers. None of these really do much to actually help the illness other than online therapists. Mindfulness apps are useful to just help like calm down at the end of the day, and mental health trackers are useful for just seeing like when you have a depressive episode or how often you do. My app, IntelliPlan, just is a scheduling app that helps relieve the burden of having to schedule every single task every single day. So IntelliPlan has a fully customizable date and time for the schedule. So you can make tasks here and then select the date and time to select to schedule it as. So you can schedule tasks for in the future, in the past, although I'm not sure why you'd want to schedule in the past, or more normally just for today. And so there's a flexible task creation system, as you can see here. You can input a name, a type for it, what day you want to be done by, so due date, how long it will take, and its priority. So whether you want it to be done like first or last, or just you don't really care. And there's also task description, which is optional, but it is helpful for just knowing what task is for. So once you enter the app, there is a home page and there is a schedule on there that you can create a new one with the generate schedule button in the bottom right corner. This will be saved and will appear on your home page every time you launch the app. And in general is just a nice reminder. It is scrollable. You can just see what it is and you can check off tasks in the task screen. So then there's also a basic profile page with user information on it. So as you can see here, my username is Keith. I'm a guy, I'm 17, and I have a biography. This can be several lines. And then you can save it, which will save it to a Firebase server. And you can also sign out, which will sign you out. So this is the flow chart for my app. So you can see here, we start on the home screen. That after a few seconds of loading progresses to the login screen, which you can either sign up for a new account, which will store your account into Firebase, or you can log into your old account. So pull from Firebase to authenticate your login information, and then go to the home screen. For the home screen with the generate schedule button, you will make a call to the ChatGPT API, which will then store its sent schedule into Firebase, which will then be pulled back into your home screen as a schedule. In the taskbar, you can see here, there's multiple pages. There's a tasks page, a ranking page, and a profile page. The profile page, we just covered, but yeah, the task page, there's an add task button in the bottom right, which will open up the new task screen. And once you do create a new task, it will save it into the Firebase cloud to be pulled onto the task screen again. The ranking page is semi-functional, but is definitely something I wish to improve in the future. It essentially ranks just like what percent of each tasks that the user has completed. And I intended it to be as a competitive system, but I may have to rethink the concept because it could lead to like people realizing, oh, we haven't done that many tasks, or we haven't finished that we haven't finished that many proportion of tasks, which could lead to like just less willingness to do their schedule. So the demo, I'm going to do a live demo because my video software is very poor. So yeah, this is the Flutter app, and I'm just gonna run it. So here you can sign in. I'm just gonna sign into an old testing account. And you can see here, this is the old schedule that I made. Here are the tasks. So this is a daily task, which I have none. This is the weekly tasks, which I also have none, and these are all-time tasks. So this is how you mark things as complete. You check them off and they will be marked as complete. And then so you can go here, generate a schedule. I'm gonna have to move this back because there's no tasks for today. And sometimes it takes a bit, but yeah, so as you can see, there's quite a few tasks for today because I was testing how many it could handle, but it works and there's a lot of tasks. And then you can hit this button down here, which saves the schedule, and it will be on your home screen for you to scroll through and just mark off whenever. Okay, now we'll go back to the PowerPoint now. Okay, so these are my experiments, which was mostly examining the consistency of my app and how well it worked. So as you can see in the top right, this is how like consistently it worked with 5 tasks of varying lengths, all with an average length of 0.5 hours across all 5 of them. And you can see it scheduled all the tasks pretty like scheduled all the tasks 12 out of 20 times, which isn't the best consistency. A lot of them, 5 of them were due to ChatGPT responding in the wrong format, which is contrary to the prompt I gave it. And then 3 times were because ChatGPT just missed a task somewhere. But of the times that I did schedule, it was the task durations were accurate 13 out of 14 times, 13 out of 15 times, which was quite good. So that's a pretty high proportion and I think is adequate for satisfying the user. And then adding breaks in was done 9 times, which is quite interesting. So this was not in my prompt actually. ChatGPT did this automatically, and I thought it was a nice feature. So I decided to measure how often, how consistently it did this. So it did this pretty often. It gave breaks 13 times out of 15, which is again quite high. So as you can see, these I tried all even times, and then I tried with one 1 hour tasks and a couple quarter-hour tasks, and then just slowly incrementing those tasks so that they are more spread out. So then my second experiment was examining how many tasks ChatGPT could schedule, essentially. So I basically just ran 0.5 hour tasks until it broke, basically. So when it would give an error, I would rerun that number of tasks again and it would see if it would work. If it didn't run it 3 times in a row, then I would stop the program. So here you can see I ran it with 30-minute tasks, 60-minute tasks, and 90-minute tasks. So with the 30-minute tasks, it managed to make it to 16 tasks scheduled, which is very high actually. I don't think there's any use case necessarily where you would need 16 tasks scheduled, so I think that's more than enough. For 60-minute tasks, it made it to 9 tasks or 10 tasks, which is again quite high. That is 9 hours of tasks, and I think is sufficient. And then for 90-minute tasks, it made it to 6 tasks, which is still quite enough, I think. So yeah. And then this is the percent accuracy chart. So 60-minute tasks were 100% accurate until it failed. 30-minute tasks were around 90-ish% accurate until it ran into the error of having a token limit from ChatGPT. 90-minute tasks were a bit less, with around 75% accuracy and consistency. So there are similar applications on the market. For example, there's Clockwise, which is similar in concept to an AI, which is also an AI scheduler, but it's made for large businesses. So it's made for scheduling and managing like thousands of users and juggling their schedules at once. And it also costs money, whereas my app is free. And Scheduler.ai is also an online scheduler, but it's an automatic booking tool for scheduling meetings in like Google Calendars and other calendar apps. So it's not a calendar on its own, it's just something to help you create a schedule or create a task item more easily, essentially. So my app is different in that it both integrates a way to schedule tasks with an actual schedule on your screen, and it's also free and for an individual user, not for juggling a massive corporation. So the current implementation is a minimum viable product. It lacks advanced features, and I used Flutter, Firebase, and ChatGPT for this. Firebase as a cloud and ChatGPT as a thing that actually generates the schedule. And then for future development, I want a cleaner like user interface. I want to refine the task screen so that it shows you a more detailed description when you click on an individual task. And I want an easier adjustment of individual events on the scheduling page, so you can rearrange them to see what fits you. I also want to enable locking an item so it's not scheduled or it's scheduled at a fixed time no matter what. And I want to make it so you as a user can set like time slots for availability on your schedule. So when you want things to be scheduled and when you can actually do things. So in conclusion, IntelliPlan helps ease the task of deciding on a schedule and makes it so people spend less time agonizing over decisions like, should I do this first?